This is the sixth block of Topic 19. In this lesson, we're going to continue to explore and apply relationships between angles and their arcs inside and outside a circle. So this is a review of Lesson 19.5, questions 1 and 2 in your notes. Number 1 says, if an angle is formed by intersecting lines such that the intersection is in the what of a circle? Well, this is inside the circle is where the vertex of this angle is. So we're looking at angle ABC, and its vertex is point B, and it's inside the circle. So that would be the first blank. Inside the circle. Then the measure of the angle, remember, is half the sum of the arcs. Half the sum of the arcs intercepted by the angle you're finding and its vertical angle. So you have two different arcs to look at. So on your notes, you will have, if an angle is formed by two intersecting lines such that the intersection is in the inside of the circle, then the measure of the angle is the sum. Remember, that just means to add. Oh goodness, it's supposed to be half. Good thing I used an erasable pen. Then the measure of the angle is half the sum, and sum does mean to add, of the arcs intercepted by the angle and its vertical angle. So that's how you have two different arcs. You have the arc of the angle you're finding and the arc of its vertical angle. So you're going to add those two arcs and take half, and that'll give you the measure of the angle. So in the example here, we are told that the measure of arc AC is 80 degrees. We are told the measure of arc DE is 28 degrees. So if I wanted to find the measure of angle ABC, I would have to add the 80 degrees with the arc of its vertical angle, which is the 28 degrees, and get 108 degrees, and then take half. And so the measure of angle ABC would be 54 degrees. Let's look at number 2. Number 2 says if an angle is formed by two intersecting lines such that the intersection is where? Well, now the intersection of these two lines is point B, and point B is outside the circle. We learned that the relationship is the measure of the angle is the difference, half the difference of the two arcs. So you can follow the sides of this angle, and here it just intercepts at point A, but here it intercepts at points D and C. So we're talking about A to C is one arc, and A to D is another arc. So this angle is half the difference, which means to subtract. So on your notes here, if an angle is formed by two intersecting lines such that the intersection is outside the circle, then the measure of the angle is half. We still have that same half relationship as when it's inside, but this time it's half the difference. So instead of adding, we are subtracting the two arcs. So in this example, we're given the measure of arc AC to be 165 degrees. We're given the measure of arc DE to be 85 degrees. So if I wanted to find this angle right here, I would have to subtract 165 minus 85, which is 80, and take half of that. So this angle here would be 40 degrees. All right, question 3 on your notes just allows us to get some practice in with this relationship that we're learning. So let's look at number 3. The question mark is for this angle. The vertex of the angle is point D, and it's inside. Now, don't make the mistake of thinking that that is the center. I just put a point at D, but there is no defined point at D there, so it is not the center of the circle. It also does not say that it's circle D. So if you see a picture and it has a defined point, sometimes that's letting you know that's the center, but this is not. Usually it'll tell you that this is a diameter or something that'll let you know that's the center. So even though this is inside the circle, it is not the center. So we don't have that central angle relationship where this would also be 80 degrees. So the vertex is inside the circle. We use number 1. Then we know that angle is going to be half the sum of the arc for this angle and the arc for its vertical angle. So the measure of angle EDF is going to be half of 80 plus 70. Well, 80 plus 70 is 150. Half of that is 75 degrees. So the measure of angle EDF is 75 degrees. The second one is wanting us to find this arc. Well, the angle that we're given, its vertex is point V, and that's outside the circle. So we're going to use relationship 2 that we just went over. The fact that the angle that has its vertex outside the circle is half the difference of the arcs it's intercepting. So if you follow the sides of this angle, you have two arcs you're looking at, arc WU and arc QT. So I'm going to set up my equation. The angle, this time I'm given, so I'm going to say the angle, which is 39 degrees, is half the difference of the two arcs. Now you always put the larger arc first, and that's my unknown, so I'm going to put X here. And I'm going to subtract the smaller one, which is 52. So the angle measure, which this time I knew, so I didn't just put the name of it there, I put the number that its value is half the difference of the two arcs. So X minus 52. Now, the first thing I would do is get rid of that fraction. So if you multiply both sides by 2, you won't have a fraction to deal with anymore. So this side, 2 times 39 is 78 degrees. When I multiply this by 2, it just gets rid of the fraction. So don't get rid of the fraction and double the things that are inside the parentheses. If you do that, you're multiplying the right side by 2 twice. So don't do that. Multiplying this side by 2 only gets rid of the fraction and leaves you with X minus 52. So now to solve for X, I can simply add 52 to both sides, and I would get X to be 130. And that is degrees because our X is the measure of an arc. I would always check it when you're solving for an arc. Is 39 half of the difference between these two arcs? Well, 130 minus 52 is 78, and half of 78 is 39. So it does work. I would always check that. Let's look at the third one here. This is another one we're asked to find the arc, and we're given the angle. The vertex of the angle, again, I do not know C to be the center of the circle. It's just a point inside the circle. So I know, and I know it's not the center because look, we don't have that central arc to angle, angle to arc relationship. They're not equal. So I know C is not the center. So if we're finding this arc here and we're given the angle whose vertex is inside, I'm using the rule for number 1, that the angle is half the sum of the arc that the angle intercepts and its vertical angle intercepts. So again, the angle's given this time. So I'm going to put 80 equals half the sum of the two arcs. Since we're adding, the order doesn't matter. I can put 87 plus X, or I could put X plus 87. It wouldn't matter. Again, the first thing I would do is multiply both sides by 2 to get rid of the fraction. So 2 times 80 is 160. And again, when I multiply this side by 2, all it does is get rid of the fraction. The inside of the parentheses part does not change. So 160 equals 87 plus X. So subtracting 87 from both sides would leave me with 73 degrees for that arc. The measure of arc RF is 73 degrees. Again, I would check that. I would add these. 73 and 87 is 160, and half of that is 80. And then the last one, we're finding the measure of this angle out here, whose vertex is K, and it's outside the circle. So we're using that number 2 relationship, the fact that the angle is half the difference of the two arcs. Now follow the sides of the angle, and you only go to point J and point L on the circle. So the two arcs we're talking about is the major arc between J and L and the minor arc between J and L. Now notice those two arcs together make up the whole circle. So they typically won't tell us what both of them are because they're making sure that we understand that they would have to make up the full circle, which is 360 degrees. So if the major arc is 260 degrees, how many degrees does that leave for the minor arc? Well, you would just subtract 260 from 360, and that leaves you 100 degrees. So now that I know both of these arcs, I can find that angle. The measure of angle LKJ is equal to, since the vertex is outside, half the difference of the two arcs. Always your larger arc minus your smaller arc. So 260 minus 100 is 160, and taking half of that gives me 80. So the measure of angle LKJ would be 80 degrees. All right, let's look at question 4 in our notes. And again, I'll just do that on the notes. It says to use the diagram and the other given information to find the measure of angle L and the measure of angle G and justify your response. That just means give a reason why you know that to be true. We have some information marked on here. Actually, we're only given one angle to be 55 degrees, but we're given some more information that's given down here. So it tells us the measure of arc GK to be 30 degrees. So this little arc right here is 30 degrees. We also know the measure of arc KM, this little tiny one right here, is 20 degrees. And so that's going to help me find the measures of these two angles, angle G and angle L. So notice angle G, its vertex is on the circle. So remember that's an inscribed angle. So this angle is going to be half of its arc. The arc we're talking about, follow the sides to F and H, is this arc right here. Well, I don't know the measure of arc FH right now. So that's one thing I need to find in order to find the measure of angle G. Well, the way I can find it is using the fact that I know this angle. This angle's vertex is inside the circle. So I know that I can use relationship number 1 from at the top of our notes, the fact that this angle is half the sum of its arc and its vertical angle's arc. So I can find this arc since I know the angle in this arc. So again, I'm going to set that up as the angle is equal to half the sum of the arc of the 55 degree angle and its vertical angle. So that would be x plus 30 or 30 plus x. The order doesn't matter. So again, I'm going to multiply both sides by 2 to get rid of the fraction. So the 2 times the 55 is 110. And again, when I multiply this side by 2, all it does is get rid of the fraction. It leaves x plus 30 alone. It does not change it. So now I would solve for x by subtracting 30, and I would get x to be 80. So now I know this arc to be 80 degrees. I can check it. 80 plus 30 is 110. Divided by 2, we're taking half of that, does give me 55 degrees. So now I know the measure of angle G. The measure of angle G is an inscribed angle. It is half of its arc, and so half of 80 would be 40 degrees. So the measure of angle G is 40 degrees. And the reason for that is the inscribed angle theorem. It is half of its intercepted arc. All right, so now let's see if we can find the measure of angle L. Angle L has its vertex outside the circle. So it's using relationship number 2, that its measure is going to be 1/2 the difference of the two arcs. So if you follow the sides of L, you go to K on the circle and F on the circle. Over here you go to M and H. So we're talking about arc KM and arc FH. And I know both of those now. So I'm ready to find the measure of angle L. The measure of angle L is simply half the difference of its two arcs. Always the bigger one minus the smaller one. So I know 80 minus 20 is 60, and half of 60 is 30. So the measure of angle L is 30 degrees. All right, so just as a review, and we have reviewed this many times, you have all of the theorems on your notes. This is a really great thing for you to study and make sure that you know all of these relationships. And the chart at the bottom is also super important. That brings us to our wrap-up question for today, and that is how The relationship between the angle and its intercepted arc always depends on where the what of the angle is located. Hopefully you